Australia is famous for opals, but hidden within the high country of northern New South Wales lies one of the largest sapphire provinces on Earth. A place where miners have recovered millions of sapphires, where diamonds appear alongside gemstones, where ancient rivers buried beneath volcanic rock still conceal untold riches, and where geologists still cannot agree on the original source of the sapphires themselves. For more than a century, miners have worked the streams, gullies and buried leads of the New England tablelands, searching for blue treasure. Yet despite all that mining, one of the biggest mysteries remains unsolved. Where did the sapphires actually come from? Today we're exploring the New England Sapphire Fields, one of Australia's greatest geological mysteries. The landscape of northern New South Wales doesn't immediately look like one of the world's great gemstone provinces. It's got rolling hills, open grazing country, scattered volcanic peaks, and quiet streams winding through broad valleys. Yet beneath this peaceful landscape lies a geological system unlike almost anywhere else in Australia. The New England Sapphire Fields extend across a vast area centred around Inverell, Glen Innes, Kings Plains, Swan Brook, Guyra and Ben Lomond. Together they form one of the largest sapphire producing regions on Earth. For more than a century, miners have recovered sapphires from creeks, alluvial gravels and buried river systems throughout the district. Some of Australia's finest blue sapphires have come from these fields. Yellow sapphires occur here, alongside green, party and pink sapphires, and even rare rubies. But understanding how these gemstones arrived here requires travelling back millions of years, because the sapphires did not form where they are found today. The story begins deep within the Earth, far below the ancient surface, at temperatures and pressures capable of producing corundum. Corundum is the mineral species that forms both sapphire and ruby. When trace elements such as iron and titanium enter the crystal structure, sapphire forms. When chromium dominates, ruby forms. Somewhere beneath eastern Australia, conditions existed that allowed these crystals to grow. But exactly where remains one of the great mysteries of Australian geology. No universally accepted source rock has ever been identified. Geologists know the sapphires did not crystallise within the volcanic rocks visible today. The sapphires are older than the volcanism itself. Something else created them. And that original source remains hidden. The next chapter of the story began during the Cenozoic. At the time, eastern Australia experienced widespread volcanic activity. Basaltic magma rose through the crust. Volcanoes erupted across large areas of the continent. And in the New England region, those eruptions would completely transform the landscape. The volcanism occurred in at least two major phases. The first took place between approximately 32 and 38 million years ago, centred around Glen Innes, Ben Lomond and Guyra. The second occurred between approximately 19 and 23 million years ago, centred further west around Inverell and Armidale. The centre of volcanism effectively stepped westward throughout time, as magma exploited major fractures in the crust. These eruptions poured enormous volumes of basalt across the landscape. Valleys were flooded. Rivers were blocked, drainage systems were reorganised, entire landscapes disappeared beneath lava. Yet these volcanoes did something even more remarkable. As the magma rose from depth, it tore fragments from the rock through which it passed. Mineral crystals became trapped within the magma, among them were sapphires. The volcanoes became geological elevators, transporting gemstones from deep underground to the surface. When the basalts eventually weathered, those gemstones were released, and that is where rivers entered the story. For millions of years, erosion attacked the volcanic landscape. Basalt broke down, streams carried sediment away, the lighter minerals were transported downstream. But sapphires are dense, very dense, just like gold. Because they are both dense and incredibly resistant to weathering, they tend to accumulate wherever flowing water slows down. The same hydraulic processes that concentrate gold can also concentrate sapphires. Over time, rivers began sorting the landscape, removing lighter material and leaving behind concentrations of heavy minerals. Sapphires accumulated alongside zircon, spinel, ilmenite, magnetite, chromium-rich spinels, and occasional chrysoberyl, and in some locations, diamonds. This process created placer deposits, natural gemstone traps formed by moving water. Some occurred in active river systems, others formed within ancient drainage networks that no longer exist. And those ancient rivers may be the most important part of the story. When most people imagine sapphire mining, they picture a miner standing beside a creek, perhaps sieving gravel from a stream bed. And while modern streams certainly contain sapphires, many of the richest deposits occur somewhere else entirely, beneath the ground, hidden within buried palaeochannels, ancient river systems that existed before younger volcanic eruptions modified the landscape. These buried rivers are remarkably similar to the famous deep leads of Victoria, except instead of concentrating gold, they concentrated gemstones. One of the most important examples is associated with the ancient Guyra River. Before younger lava flows spread across the region, this river system transported sapphires, zircons, and diamonds through the landscape. Later eruptions buried sections of the drainage beneath basalt. The river vanished from the surface, but the gemstones remained. Modern geological reconstruction has allowed parts of these ancient drainage systems to be traced beneath the volcanic cover, and some remain highly prospective exploration targets today. The richest deposits are often surprisingly localised. Studies of heavy mineral assemblages across the New England Gemfields reveal significant differences between neighbouring catchments. Different streams contain different mineral suites, different sapphire colours, and different gemstone populations. This suggests that many sapphire sources were local rather than being transported across enormous distances. In other words, each drainage system may tell its own geological story. This observation has changed how geologists think about sapphire concentration. Older models emphasise long-distance transport, but evidence increasingly suggests that many economic deposits formed through intense reworking of nearby basaltic rocks and volcanic sediments. Weathering released the sapphires, streams removed lighter material, and over millions of years, dense gemstones became concentrated within specific channels. The result was a natural enrichment process. Nature effectively performed its own gravity separation again and again for millions of years. The outcome could be extraordinary. Some palaeochannel deposits have recorded sapphire grades exceeding 500 grams per cubic metre. That may not sound impressive at first, until you realise these are gemstones. Not industrial minerals, not sand and not gravel, but gem-quality sapphires, concentrated within narrow channels hidden beneath broad basalt-covered valleys. Miners learned quickly that these deposits were not evenly distributed. Most of a valley might contain very little sapphire, but a narrow buried channel could contain a rich pay streak, just like a Victorian deep lead. Finding the channel became the challenge, and finding the pay streak became the reward. Commercial mining eventually expanded across the region. Operations around Inverell, Kings Plains and surrounding districts produced vast quantities of sapphire during the 20th century. Mechanised mining replaced simple hand methods. Wash plants processed enormous volumes of gravel. International buyers arrived, and Australian sapphires became recognised around the world. Yet despite more than a century of mining, some of the biggest geological questions remain unanswered. The greatest mystery concerns the original source rocks. The volcanoes clearly transported the sapphires, but it did not create them. So where did they originate? Some researchers point towards unusual crustal environments associated with the New England origin. Others suggest deep magmatic systems. Still others favour metasomatic processes operating near the crust-mantle boundary. The evidence remains inconclusive. Even the rare rubies found throughout the district add another layer to the mystery. Recent studies have identified unusual chemical signatures within some New England rubies and sapphires. High chromium, high gallium. Distinctive trace element patterns, unlike many other ruby occurrences worldwide. These characteristics suggest a unique geological origin, but exactly what that origin was remains uncertain. The sapphires continue to guard their secret. And then there are the diamonds. Thousands of diamonds have been recovered from parts of the New England Gemfields. Some occur within the same palaeochannels that host sapphires, yet no definitive source has ever been identified. No major diamond-bearing kimberlite field has emerged to explain all of the discoveries. Just like sapphires, the diamonds remain part of the ongoing geological mystery. Perhaps the most fascinating aspect of the New England Sapphire Fields is that they are not simply a mining district. They are a geological puzzle, a place where volcanism, erosion, ancient rivers, and deep earth processes intersect. A place where gemstones travelled from unknown source rocks, were carried to the surface by volcanoes, released by weathering, concentrated by rivers, and buried beneath lava, then rediscovered millions of years later by humans searching for treasure. And despite everything we have learnt, much remains hidden. Buried palaeochannels still lie beneath the basalt. New gemstone deposits may still await discovery. And somewhere beneath eastern Australia, the original source of the New England sapphires may still be waiting to be found. More than a century after mining began, the mystery remains alive. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.